$300,000 per hour. That's the average cost of downtime across industries. And almost half, 46% of all companies that experience downtime aren't able to serve their customers as a result. Wouldn't it be nice if you could apply the principles, strategies, and tactics of the most successful sports teams, like the ones in the NFL, in the form of a playbook tailored to you, a resilience playbook that you can use to train your teams to become resilient to the unpredictable? What do you think, Olga?
I think it's a brilliant idea, Lauren. And I think this is exactly why we're here today. Prime Video has been streaming exclusively Thursday night football 2 years in a row. And a few years before that, we're also streaming it and co-sharing with other partners. This year, our audience is 26% up, which basically means more than 12 million customers are joining and watching football each Thursday. This is amazing. We've done this for a while. We also have learned and recognize that preparing engineering teams for peak workload and for peak streamings is very similar to how teams prepare for getting to Super Bowl. So what we've done, we took all of the lessons, practical insights, stories, and we created a resilience playbook that we'll be sharing with you, all of you today from this session, so you can take it home to your home teams. My name is Olga Hall. I'm a director of Observability and Resilience Engineering in Prime Video Sports. And together with me today is Lauren Dom, who is Chief Technologist, focusing on financial and federal sector, and also has responsibility for chaos engineering worldwide in Amazon Web Services. Thank you for joining us.
Thank you, Olga. And great to be here. So today, we're going to go into building that winning mindset that you need as a team to be successful when you're thinking about resilience. And you start doing that when you're thinking about a goal, a common goal. Now, once you have that goal, we're going to walk you through how you need to think about training your teams the same way as they do it in Prime Video. You're going to look at the predictable. We'll then go into more of the experiments and thinking about what can go wrong when you're looking at resilience, the unexpected. Then you need to think about how do I analyze the various aspects that you learned. We're going to show you that and go into the aspects of how should you memorize the various learnings so that next time when something happens, you're going to build muscle memory and you're going to be ready for it.
OK, let's start with a little bit of reminder. Most of you know Prime Video because you have your favorite shows. Maybe it's Jack Ryan. Maybe it's forever favorite for me, Marvelous Miss Maisel. Maybe it's Citadel. There is millions of titles in our rich catalog. Prime Video also streams sports. Tennis, baseball, volleyball, New Zealand cricket, you name it. We are super happy to be an entertainment hub and delight our customers with sports. We have about 50,000 events just this year that we streamed worldwide. When we prepare for this season, early in the year, we start thinking about, OK, what is our main mental model? How do we succeed preparing for global events with distributed teams? Inevitably, year over year, we go to the same mental model. Think global, act local. As we go through the presentation today, I will point out examples where this is actually happening and why we did it the way it worked. But in general, just to start us off, why there, right? Why start there? At global level, we agree on goals, we agree on programs, we agree to allocate certain resources, we agree on certain work streams, and then we provide guidance to our teams that take this guidance and bring it home so they can execute independently for these globally streamed events.
So when you're thinking about these 200 countries, and you've been streaming Thursday Night Football for quite a while, and I see here Black Friday football. I mean, when I think about Black Friday, this is excitement, and you have people running in stores, and you know. But how do you prepare for these unpredictable conditions?
Well, Black Friday has been absolutely super special for us. We hope we've established a new NFL tradition. But if you think about it, it's not that unpredictable, because on the Black Friday, what do we have? We have family, friends, enjoying time together, and hopefully enjoying time together watching football. So we can make certain assumptions about audience and what the audience will do, about customer behavior. The things that are unpredictable, they're a little bit tougher. You cannot predict really weather and what will happen on the match. Little known fact that I'm going to share with you, the very first time Prime Video streamed TNF, it rained out. Completely, totally rained out. The game was held, postponed, and then we had to prolong it for a significant amount of time. And those of you thinking, well, so what's so big deal about this? Well, the peak workload that comes with that had to run much longer than anticipated. And we had to think about those scenarios. What if that peak workload time gets extended? Do we need to test for it? Do we need to prepare for it? So those are things that can impact you. Team makeup, what happens with the player health, how that is real time and can impact also how the audience shows up. Absolutely unpredictable. And the last thing is, we're living in this cultural moment, all of us, where a certain celebrity that a lot of us loves happened to be a fan of Kansas Chiefs. And with her, there is new energy and there is attention that coming and enjoyed by NFL fans, and NFL hard to predict in advance, right in the beginning of the year. Most of you probably thinking, well, how do I find those unpredictable things? Well, those unpredictable things very often show up from newspaper or maybe your news feed, however you get your news. Very often, they're also thoughts on the back of my mind. Ooh, what if this happens? What I do? And my question to you is, what is your playbook for the scenarios? And if you don't have one, that's okay. Take maybe some insights that you're going to take today and bring that playbook home and create one with your teams.
And when you think about your playbook, you need to build that winning mindset. When you look at the winning mindset from successful sports teams, there's one thing that all of them do, and that's they practice like they play, and they play how they practice. They create muscle memory, they visualize what they're doing within the games, and therefore understand how to perform at peak. Olga, talk to us about how Prime Video is practicing and getting to the peak.
I like what you said, create muscle memory. So the way we create muscle memory, Prime Video has the program where we run load tests, automated load tests, 3 times a week in each region where Prime Video runs. We calculate what that peak will be. Sometimes it's on a weekly cadence, sometimes it's on a monthly. We find that peak, and we basically run the load tests, we call them game days, to make sure that we have certainty for auto-scaling rules, testing our auto-scaling, testing response of our teams. And for those of you that are thinking, ooh, this could be a little bit intense, well, this weekly testing for peak what it does, it trains that operational muscle memory for our teams, keeps the code path fresh, helps us identify bugs that might be showing up at scale, and it also keeps the muscle of our teams super fresh.
So when you're thinking about that winning mindset, you need to have a goal. Can you share with the audience how you were able to gather the troops and create a goal that everyone was behind it?
Absolutely, happy to share. So as I said, when we start at the beginning of the year and thinking about, all right, new season is coming up, what do? We agree on the fact that availability is our feature number one. We take a specific goal on how we want to raise our availability bar for certain services or maybe across the product. And then we have a tenet that basically says availability is feature number one. This is not just a saying. Imagine yourself sitting in the room with the product leaders and engineering leaders where you have a ledger of new features that you want to build, and right on top of that ledger, there is availability work streams and availability projects that are funded, they have resources, and they have support of a leadership. Before I get any further, what I want to do, let me share with you the definition of availability as we use it in Amazon Prime Video. We've tested over the years, we've practiced it over the years, kind of like it. So for us, availability is an emerging quality of distributed systems where each critical components cooperate, collaborate, and protect from risks. What is interesting in this definition, it's not just software, right? There is leaders and there is teams, including in this definition as well. And speaking of terms of leaders, I didn't have to go too far. Prime Video Vice President responsible for and being a global head of sports, Jay Marine, talks about availability at every single meeting with his engineering and product teams. And he could be heard hearing very often something like this: customers are passionate about sports, and we're committed to providing a seamless, high-quality viewing experience. And he talks about this at all hands, and he discusses it during our features review. When you have this leadership support, it's easy to create a structure for programs. So let me show you guys how the programs are structured. So in the first work stream, we have projects that are related to operational excellence. We developed, and we're going to share it today with you, an approach mechanism that we call operational readiness score. And we basically agree with the teams what goal, what number they want to take for achieving an operational readiness score this year. And we'll share that algorithm with you just in a moment. The next set of projects, I really focused on service resiliency. What does it actually mean? So again, in the beginning of the year, or as the year progresses, teams are thinking, what contingencies do I need to have? What failbacks do I need to have? What levers do I need to have? How do I dial up features up and down? How do we test that? So all of that gets aggregated in a very specific program, and we call it service resiliency. And we're going to dig a little bit deeper how this program looks like. The first two things are not as successful without observability and reporting as they can be. So to make absolutely movement going forward year over year and improving the availability posture, you need to invest into observability and reporting. And I'm happy to share today some examples what we've done for observability for services and connections between endpoints. And I'm going to highlight some reporting that we also do for availability.
So when you're thinking, when you're thinking about an operational readiness score, Amazon Prime Video did a lot of research when it comes to understanding what is critical to build an operational readiness score. You see 4 pillars here, from deployment safety, code coverage, operational readiness completion and review, and correction of error actions. Now let me show you how this looks like at Prime Video. They've built a resilience portal that provides transparency in regards to the health of every service that you can imagine that incorporates Prime Video. There is a catalog that automatically ingests new services that developers create. You can analyze those services, as Olga mentioned, through those game days. You get reports in regards to load testing and the health of these. And then the operational readiness score that is very important for the developers, but also for the leaders as well. We're going to also look into scenarios and how these are applied to Prime Video, and then how the insights aspect works in regards to observability. Now, the operational readiness score can have 100 points. And these 100 points are comprised of 45 points for deployment safety, 15 points for code coverage and correction of errors, and another 25 points for the operational readiness review. Now, there is a reason why there is a heavy weight on the deployment safety, because when we're looking across the entire customer base, most errors happen during deployments. The other aspect is you want to have a safe environment for your developers to innovate. And through these scores and the various aspects and mechanisms that we provide, we're enabling developers to do so. When you're thinking about deployment safety, we wanted to share with you a few items that you can use as well in your own environments. For example, implement automatic rollback. That will allow you to get very quickly back to a stage where you can operate. Think about, especially if you're operating in AWS, start with deployments into an availability zone, roll out to multiple others availability zone, then to the region, and do the same in another region. And then additionally, you want to make sure that always that you have 66% of healthy nodes when you're provisioning. And that, again, is to ensure that you always can serve your customers. Then you can think about code coverage and code reviews. And this is not just about understanding what the percentage is of tests that you have on your code. Prime Video also is looking at the failure handling in regards to pipelines and faults that happen in there. The aspects in regards to reusability of design patterns that you know work and are resilient. And then also around the dependencies, because they're key when you're thinking about a distributed system. We then go into the operational readiness reviews. And when you're thinking about operational readiness reviews, this is the same thing when you're thinking about a sports team that huddles in the room before a game, and you create a plan where you know this is the goal, we have best practices across what we want to do in the place. And here, you're looking at the security best practices, the deployment safety that we just talked about. How does the service predict and does scale and load? And then especially around event management, incident response, to be ready if something goes wrong. To be able to do that, of course, they need alarms and metrics to be in place and current so that it can be executed on. And then lastly, for the unpredictable, having availability reports and impacts and chaos engineering to ensure that they're ready in regards to faults and failure that may happen in the system. Now, all these points, as you probably have seen, they're all additions. And so, Olga, when we're thinking about the operational readiness score, how do you ensure that actions out of, for example, faults are actually implemented?
Absolutely. So we have a process that we call correction of error. Many of you know by industry standard name, which is root cause analysis. Those of you that are following AWS blog, for example, during incidents and read about it, this is your traditional RCA. This is very structured. It has customer impact, timeline, what happened, 5 whys, lessons that we've learned, and fundamentally actions. And very often, I advise the team when I work with the teams to focus really on the actions. Actions are the key for preventions. The world of sports, your world, doesn't matter in which industry you are, maybe it's news, maybe it's healthcare, maybe it's finance, you know, there's plenty of work and there's always the conversations about trade-off. And there is conversation about, do we hurry up and maybe finish up some new features that we want to release? Or do we need to focus and strengthen some of the learnings that we have from past COEs? So the mechanism, the COE review and correction of error, helps us to basically say, hey, if you have this lingering points, the lingering actions from COEs that are not getting addressed, we're going to take points away, which basically what it does, that operational readiness score, it's not once and done. It's a living, breathing thing, almost like a temperature check that at any given point of time, you can take a look at the operational readiness score for your services and basically make a reasonable assertions and assumptions what's going on there. Are we going up, are we trending down, and what are the reasons are? So it becomes a mechanism for leaders to keep a check on resilience and availability of their services.
So we talked about defining the goal, rallying the troops, and then how you can ensure that your teams are performing as expected through an operational readiness score. But you may think, is the service that I have really worth the sweat? And the way on how you can define that is when you're thinking about your services, is the component you're working on customer impacting? Does it serve many upstream or downstream dependencies? And if that's the case, you know that the investments that you can make in operational readiness scores is well worth it. So to make it easier for you to think about the entire journey in resilience, we created a mechanism for you that is called team, because resilience is a team sport.
Resilience is a team sport. And the reason why we did it, Lauren and I, because look, there will be tons of conversations, tons of information coming your way, right? How do you sort of like create a structure that's easy to connect with? So in our discussions as we were preparing for these sessions, we basically said the world is actually really simple, if you abstract a little bit, right? You can have two slices. One slice, things that are predictable, forecast. Maybe customer behavior, right? What customers will do on a certain day, you can predict this. Yeah, there will be variance, maybe a degree of risk, but it's predictable. And then there is unpredictable events. For predictable events and predictable inputs, as we call them at Amazon, we train. We train our teams for predictable inputs. For unpredictable inputs, we experiment with. It's kind of hard to train for unpredictability, but you can experiment with and you can learn it. We collect the data, we aggregate the data from both cases, we analyze it, we review it, we take the learnings, we put it out in our operational memory, and we repeat the cycle again. So let's start with the training. I want to start there because it's sort of like area number one. So what do you mean, right? You can ask me. So let's talk about what do I mean when I say forecast. For those of you in streaming media, the key metrics that define what's going on for peak workload are actually pretty simple. There's a concurrent streams, how many customers we're going to have at peak, right? The second metric is stream starts. The saying last minute is actually last minute is so true. 5 minutes before the game, we've noticed that the customer behavior is pretty much, doesn't really matter. EPL, English Premier League, TNF, you always have, or we always see this spike in subscriptions that happening, right? So you can, and the stream starts helps us to basically make assertions how fast customers will be joining. The other things that you can predict is, hey, maybe it's a tie. Maybe it's Messi playing on English Premier League, right? And there is some moment that everybody is going to come in. What is that peak TPS that may happen on the services for stream starts? And the third metric is going to depend on your business. This is your ingress point, where the customers are coming full force in one place, right? For us, it's detail pages where customers are landing and are ready to watch a certain show. I'm sure that for all of you, if you think and brainstorm a little bit, you can identify those key metrics that define your business, right? What we also learned over the years, that all services and endpoints that we have that scale with one of these metrics, which basically means that we can develop algorithm based on ML and AI that helps us to predict these three main business drivers and apply similar algorithm to the service level metrics, so we have the forecasting at all individual endpoints for the services and the customer journey that are involved in supporting sports events and supporting our product. Last not least, because it's streaming media, it's not just services, there is obviously throughput that we need to think through, and this goes to CDNs and ISPs. Okay. So the question is, now that we have all of these inputs, what do we do with them? And this is where fun begins. If we know a TPS, right, for your endpoint on a weekly basis, and if we know what we forecasted at peak for the event, you can see that you can easily create load testing for each individual endpoint. What we do in Prime Video, we created a tool. We lovingly call it Wally, and this is a game day tool. What it allows us to do, assemble multiple configuration so that we have this one game day that comes pretty close to what we see with production traffic and peak workload footprint. This is where we can model a load for subscriptions, for playback services, maybe for advertisement, whatever scenarios that we can think of that will be having different ramp-ups during the game. All of them are running in parallel with this approach. And the reason I want to make a stop on this, and this is super important, because this is where global versus local come into place. Our teams, our two pizza teams, they own individual configurations and load generation for their endpoint. A central team will come up and create this load profile that matches the profile of the event or a sport that we will be playing or running and preparing for.
So I'm a little bit confused. So in the beginning, you had this slide where we showed that your teams are running 3 times a game day a week. When we in AWS, we run a game day, we have a room full of people, we sketch out everything. How are you able to rectify that amount of work with your teams?
Gone are the days when we had engineers in the room. And yes, I was a technical program manager sitting with engineers in the room in the middle of the night running those tests. We automated it. Right now, with this configuration tool, it's just a matter of a few clicks and one person that schedules that game day and fundamentally watches over the game day run. It is true, for those of you who are following chaos engineering, yes, Prime Video experiments and run these tests in production, which basically means that we have technology to stop a game day or stop experiment at any given point where we see a sign of trouble and whatnot. And a lot of it is automated, but there is also a game leader who can do the same thing when it's needed. So it's click of a button, and it's one person.
So how, when you're thinking about it and you're running this automatically, how are you confident that nothing is going to go wrong being able to run this automatically?
Okay, so this is where we said the word is kind of simple, right? We can predict what the TPS per each individual endpoint is, and we can watch on the monitors and alarms and have high degree of confidence that things are going well. And if they are not, we'll stop, pause, we learn, and we do this experiment again. So in essence, let's take a look at the playbook for the game day. Specifically, in Prime Video, when we say load testing, this is our game day. We start with a forecast. Next, we develop different scenarios. All sports are different. Thursday night football I enjoyed on living room the most. However, if you take Japan boxing, especially with the timing window that was happening this window, it's mobile because customers were traveling at the time. Or if you take New Zealand cricket, for example, again, it's mobile first. So you basically create those scenarios that are specific for the launch that you're preparing for. Teams update their load generators. They maintaining it at a local level. We make sure that we instrumented observability and we're keeping eyes on the health of the services. And the last piece, it doesn't get enough attention, and I want to stress it a little bit higher. When the game day is run, there's reports and there's findings, there's tickets that are issued for the team. And that's why we run those game days, because you can take those fresh findings, you can put this, or teams will put this in the technical debt tracker, and they go into your sprint right away. So as the team does sprint readiness, remember when I said availability feature 1? They look at all of their issues that is in their sprint, and their availability items will be always on top. So for them, it becomes a little bit easier to prioritize and focus on fixing the findings from the game days.
So we looked at starting the team off with a goal, then operational readiness scores, and the training. And we know now what the predictable is. Let's look into what Prime Video is doing in regards to the unpredictable and experiments. When you think about putting the resilience to the test, there are various ways on how you can do that. You can run ad hoc experiments as you usually see them in game days, but you also should run them in pipeline. Because if you have them in the pipeline, you can have a blocking pipeline if you're introducing a fault so that you can quickly roll back instead of provisioning into production and impact your customers. You can also run them in a scheduled way, the same way as Olga mentioned with Prime Video. Now, when you think about the unpredictable and putting resilience to the test, it's not just about the tech, it's about the people, it's about the processes. Think about when was the last time when your core database admin, for example, went on vacation and the system went down and nobody could log in. Probably every one of us saw that before. Now, when you think about chaos engineering experiments, they're always associated with risk. And you need to understand which ones are low risk, which ones are high risk, which ones are medium risk. Especially if you're starting out when it comes to chaos engineering and chaos engineering experiments. You can start with, for example, CPU and memory hog. You can run some pause.io experiments to understand how is your database, for example, reacting to those pause.ios. Or you can do simple things like restarting EC2 instances that are behind an autoscaling group because you know they should come back up. The same thing with Kubernetes or with ECS. When you kill a pod or a task, it should come back up. You can then move on to medium risk experiments, and they're very interesting because many times we say, yeah, infrastructure failure, that's easy. But if you start injecting latency, you're going to learn a lot about your dependencies and how they react to latency. And so inject downstream, for example, latency into services, increase error rates, and see what happens. Now, one thing that we thought is interesting to share is how Amazon Prime Video is looking at the medium risk items because they're not just running it ad hoc, but also in pipeline.
Absolutely. And I must admit, this is one of my favorite slides because this is super actionable. So if you're taking a picture of the slides, that's probably the one that you might want to snap. Why? Because the low risk items, engineering teams at a local level, they can get started and do this at any given point of time. You don't have to have a central program or central planning. They can get into the routine of experimenting and testing independently. What we also do in Prime Video, some of the game days that we run was load testing. We will run those low-risk injection as well for the sake of learning. Okay. The middle pipe, medium risk, I came to appreciate it with time, and I absolutely love it, highly recommend it to work with your teams to put it in your pipelines. Why? Because very often when you walk the hallways or if you're listening to the Slack chatter, how many times do you see a conversation, hey, I just committed this function and it has 50 milliseconds increase. Do we need to renegotiate SLA? And sometimes you see that back and forth. It doesn't really matter which company, be it storage, maybe news, maybe media. We live in the distributed world, right? So our services are integrated and dependent on each other. If you have those tests in the pipeline, the negotiations are just done. You run the tests, starting be it 50, 75, 100, whatever that is, but you have confidence that if something changed in the contract of your dependencies upstream and downstream, you have confidence that it didn't break the chain. That's why I love that middle part. And then high risk, this is an example where the global work comes together. Yes, this is when we will be in the same room with technical program managers and engineers, and we basically run experiments of how quickly we can shift workload between different regions, for example. And that is a high-risk experiment that we will plan at a global and central team level.
When you're thinking about enabling our customers in AWS so that you can understand how your workloads react to faults that happen in the resilience of the cloud, you have fault injection service. And for those high-risk experiments that you just saw, we just today released new faults for AZ availability, power outage, and also regional isolation faults that you can use if you have multi-region services and you want to see disaster recovery and isolating a region and how these workloads function.
Fantastic news. Can't wait to start using it. Keep going.
Perfect. So additionally, when you're looking at fault injection service, over the last 2.5 years, and this year we released quite a few new faults. If you're using EKS, for example, you can now inject faults into the pods directly, like latency and CPU and memory. When you're thinking about ECS, you have very similar faults that you have here too. We enable you to inject faults into EBS, thinking about POS.io, but then added a lot of network faults that you can go and run. Keep in mind, these are not just simulations. These are real-world faults. And you need to understand how your workloads or applications react to those faults. So you have the power to go and execute them. Let's look into how Prime Video is running chaos engineering experiments. You've seen the resilience portal in the very beginning. And when a team wants to run chaos engineering experiments, they first go in the tool. Olga talked about the forecasts. When you think about an experiment, you want to have a steady state. Therefore, we start increasing the load based on the forecast that the team has. We then define the experiments. You see two specific tools there with fault injection service and SSM Chaos Runner. SSM Chaos Runner predated the fault injection service and also enables Prime Video to get kicked off by a pipeline and automatically with a library. Now, once that experiment is executed, we of course want to do that in a safe way. There are already metrics and alarms defined in CloudWatch so that if the experiment would go out of bound, it automatically would stop.
Yes.
And all logs and traces that you have for observability flow into the resilience portal in regards to the insights that they have to be able to act and understand how to improve the system. So let me show you how Prime Video does that in regards to the pipeline. When you're thinking about chaos engineering, we see that with many customers that they build an interface across the chaos engineering tooling so that they expand the amount of faults that they can create. In this case, you see that we have a library for SSM Chaos Runner that can run in pipeline that calls fault injection service. You see the action that we're going to execute here with IO stress. You have the tags that you can define to ensure what is your scope of impact, as well as the duration and time and the stop condition to have safe experiments. And that brings me to the dress rehearsals of Prime Video that are the game days, the chaos engineering aspects that we're executing.
This is another place where we have a lot of fun. So as you can imagine, there are preseason games that NFL runs, right? Sort of like warming up the players, warming up for preseason and everything else. Prime Video gets access to these preseason streams, and this is where we test our features. Okay. Usually it is a beta room, and we call it the beta program. It's done during beta. And yes, teams could be virtual. They could be sitting in the same room, but highly distributed, so it's a combination of both. What happens during this beta, so dress rehearsals as we call them, we don't tell the teams what are we going to run. They don't know. They're just going to know that there are some experiments that we're going to do. I'm going to share with you my favorite one. So not all of it can be technical. Some of it, you can imagine, teams are testing the features and whatnot, and somebody does an error injection, and you're going to have to figure out if it's real or not. But one of my favorites this season was bad QR code. We declared that we had a bad QR code that needed to get down. We studied the work to figure out where it is to find it and then pull it off. We measured our mean time to detection. We measured mean time to resolution. Our engineering teams were pulling levers to kind of take this bad QR out of the system right there on the fly. Our press release team, marketing team, absolutely loved it because they were not aware that we're going to do this. So they had to figure out, what they're going to do, what their playbook will be. The same as the production team was a little bit caught by surprise, and they had to also figure out on the fly, all right, what is the process that they need to follow for that. We run it as an incident, and then we take all of the findings and do retrospective on this. And fundamentally, in many other teams and businesses, this is called a tabletop exercise, a simulation, super powerful. Every single time when we run it, we've got really great feedback, both from our production teams and our engineering teams. So let me dig a little bit deeper what else we do, just to show you guys an example. So the thing that we've decided in Prime Video is that every feature for sports that we have is going to have a feature flag, which basically means we can pull it off super quickly. Why would we want that? Well, we have such a feature as rapid recap, for example, right? One of the favorite features that our customers love. If we're not necessarily happy with the highlights of the games that's been selected for rapid recap, we can take it off, adjust, and pull it back again. And that's one of the examples. So you can do it basically real time. So during dress rehearsals, as we're preparing it, we've been testing all the new features that we created for this season, how long it takes us from the moment we declared something is off to fixing it and putting back up. Okay. I also love the fact that when you do these unannounced experiments, our alarms get refreshed, and our engineering teams, I see somebody smiling in the room, you probably experienced something like that, but absolutely, that's true. Our engineering teams are starting to look at their alarms and basically saying, hey, we need to make sure that we're tuned and we have precision and we can sort of like separate the noise from the real thing. Retrospectives. We run retrospectives for these experiments. And why this is also good, because debates very often are, hey, do we need to automate this? Do we need to go with what we have? What else can we do so this is real time? In sports, there is no room. Everything is real time. There is no room to lose any specific moment of the game. So that's the reason we practice these things. I'll talk about one more thing. Sometimes weather comes into those discussions. It's super powerful, but not obvious. We have this tests where we also test chime going down, Slack going down. What if there is a power outage? We have a hybrid team sitting in different locations, but weather is not predictable. What if people in London cannot get to the tube? What happens if there is power outage in Seattle? So you kind of work through that scenarios as we do and have redundancy built in, and we practice it as well.
So when you think about from the start, we looked at the definition of goals, how you can track them with operational readiness score. We looked at the predictable in regards to training and the unpredictable. So you take learnings from these and you analyze them. Let's go into how you're thinking about the analysis of the various learnings.
Yeah. So what's the process for that? So the mechanism that we have, like I said, it's correction of errors. It's super structured. One thing that I hear sometimes being asked, is it just engineers who get it? Do we need to have managers sit down with us as well? It's a huddle. It is engineering teams that are involved in the incident or near incident. Sometimes we'll do a COE if we didn't impact the customer, so it came very, very close, and there's something significant to learn from this, right? And the managers, senior leaders are also in the room reading this document and discussing. Why? Because fundamentally, as probably many of you experience, when it comes to the launch, right, this is a game time for decisions. What do you prioritize? Do you hold certain features and work more on operational excellence? And we have done it over years where we said, actually, here's what we've learned. We need to strengthen X, Y, and Z, and we're going to release certain features mid-season and whatnot. I'm going to show you, as promised, what we've done for observability, because this is super powerful as well. We've created a service graph that shows us connections, all of the different services. And the cool thing about it, the link is going to be highlighted in red if we determine there is an anomaly in the log files and connecting this to services, or if we have CEF2s, alarms going off, and whatnot. So it's real time. It's super powerful. I know that many customers, and many of you probably doing this already. The thing that I want to highlight that I thought was super clever, how our engineering teams did it, because the service graph, right, it can be super unruly and can become this big glob. So we created views by customer journeys. So we can have a view on subscriptions, we can have a view on playbook, we can have views specific to detailed pages. And being able to navigate through the views real time and having visibility real time when things are in trouble and they lit up, super powerful. And another thing that we've done, we debated should we do it or not a while back, and we found over years that was a great investment. We have real-time availability dashboard. We selected a few key services within this customer journey, and it's basically near real time, shows to everybody what the availability for those endpoints is. There's no questions, there's no guesswork, it's just exposed and everybody has their eyes on that. Very often I hear a question, when I speak to customers, speak with many of you, even with our own engineers, what is an ROI? Prove it to me that chaos engineering work. So I'm sharing with you this graph on incident severity. It's a real graph from last year. We've learned a lot last year. And basically what this graph shows is how we started the season, and we had some incidents that we needed to work on. We applied the processes that I'm describing. It's a game times, it's drills, it's making sure we do those chaos insertions, and we've done much better by the end of the season. So when this happens, you can see that mean time between failures improved, and it becomes much larger. And mean time to detection, mean time to restoration shrinks, and that's exactly what you want. So we have conviction that availability, it is feature number one, and we're investing in it on an ongoing basis because it does get us the results.
Exactly, and when you're thinking about the availability and the resilience, it's not possible without observability. Next, we're going to go into the memorize phase. And when you're thinking about the memorize phase, it's a lot going back to the roots that we had in the beginning. You need to have that objective for your team. What is it that you want to improve? Once you know what you want to improve, you can start creating a plan. You can visualize it on where is it that you want to go. You can then start defining a strategy around the predictable patterns that you usually see in your customers' traffic. And you can get more comfortable in running these various game days, as Prime Video is doing it, in an automated way, pre-warming your systems, understanding how they work under load, injecting predictable faults where you know they should be able to recover based on auto-scaling groups, for example. And then move forward to experiments where you begin to challenge the teams a little bit, define a clear hypothesis in regards to how the system should behave, and verify that your hypothesis actually becomes true to game days or dress rehearsals as we have it at Prime Video. And then, very importantly, when you're thinking about memorization, it's understanding your graphs. When you think about observability and understanding of what happens, is you start always at your steady state. That's the transactions per second. That's the stream starts per second that you need to see. And if you see impact, something is going down, and you can drill in and understand and analyze what you can do better. That's the fine-tuning piece. And if you do that over and over again, you begin to have that operational muscle memory that you can execute at peak. Additionally, and not to forget, is the runbooks and playbooks. You want to ensure that when you run and memorize these various steps, that your team members know what is their role and how to execute if there is an incident. You don't want them to go and search where in the wiki is that page where I need to click. They all need to know in their sleep on how to execute it. Right. And here you see that. You have various buttons for the call leader, for example, for the subject matter experts and other roles so that they know right away on what they need to do.
Yeah.
And with that, Olga, get that touchdown.
Get us to the touchdown. Okay, so I've practiced this a lot. Let me try it. And this, how you get to the Super Bowl. No, all right. We use the word memorization a few times. Why? The reason we keep insisting on this, because in Prime Video, especially in Prime Video Sports, we're in the business where each second matters. You cannot lose a single second, right? So fundamentally, this means that you don't have time to think, debate. You have to pre-cache decisions. All of the logic of what your operational response is needs to be in your muscle memory, as Lauren keeps saying, being a former tennis player. So it is part of the muscle memory. And in summary, how do you get to that muscle memory for those of you who might be in finance or healthcare or other industries where real-time response is super important? Here's a playbook. Think about what's predictable. Think about what's not predictable. Train for the inputs that are predictable. Experiment, improve, things that are not. Develop your scenarios for predictable things. Create your own mechanism. We shared with you operational readiness score. It doesn't have to be 100. It needs to work for your workload. It needs to work for your organization. You can use the logic here to develop that mechanism as the way you see it fit. We've been happy with that. Develop the game days, be it workload testing, be it case testing, maybe a combination of two. Remember that slide with 3 buckets? Super powerful. So develop those systems. The dress rehearsals doesn't have to be just tech. It's the things on the back of your mind that are nagging you sometimes. What if this happened? We'll play it out. What are you going to do, right? Bring actionable insights, update your runbooks, playbooks, and all of that is going to get you to proactive reliability.
So with that, go build your playbook. We showed you in this session how to assemble your teams, thinking about that winning mindset and how you should look at it by defining a goal for your teams so that you can rally the troops. You now have seen how you can adapt in regards to game days, for example, running forecasts and load tests against your system multiple times a week to understand how they work, and then how you should think about experiments and run them continuously within your environments. Go and define how you should think about blameless learning and the analysis that you're going to do so your teams can learn in a comfortable way and grow. And then memorize, train them, help them to understand how the systems work and give them environments where they have the freedom to do so. And so all of these steps can be summarized again in one sentence.
Absolutely. All you have to remember is just one thing. Practice like you play, and play how you practice. What a wonderful thing that we've got from sports, highly applicable to our engineering teams. Thank you for joining us today, and we will be happy to take your questions.
Thank you.